Okay, members, let's start our lesson right away. We are going to make corrections as you're well aware. I think your papers are ready. And I need to take this opportunity to thank everyone who participated. Unfortunately or fortunately, I saw papers of some people whom I had never seen in class. There are very many people who did the paper and I'd never seen them in class. I don't know whether maybe I've forgotten with my learners. I don't know. But I've seen people there. I've marked all the papers. The performance was good. That's what I can say. And trust me, if you people can maintain on that track, then eventually we shall have something at the end of it all. It is so unfortunate that we shall not be meeting on Zoom live lessons, but we thank God we shall be recording videos and sending them to our YouTube channels, where you'll be watching all the videos from there. If you don't have the link to our YouTube channels, please make sure you get it. It is Christian School Owners Association. You continue with it that way. If you can also have a private teacher, I would suggest you can get also the teacher so that he can continue from where I stopped. Make sure you do that so that at least we keep the fire burning. See, it's going to be a long holiday if we say that we are going to wait until when the open schools is going to be very hard for us, because by the time the open school, our heads are not computers that does not forget. It's only a computer which does not, which at least it can store things. So our heads are bound to forgetting. So we need to keep ourselves active on the line of academics. So I would advise that if you can get anyone to coach you there, well and fine, please get one. You can join an online school, well and fine, please join. If you don't have any access to any online school, then you can contact me. I get for you one which can help you, because we have the list of schools which have taken up these live Zoom lessons. So for us, we shall be on what? We shall be on YouTube only. So if you can join those schools, if you don't know them, you can contact me. I can take you through where you can have your lessons continuous. Remember, they will have all the subjects, and so you'll be like you're still in class. They are not expensive, so I'm very sure you can afford them for those who are interested. Allow me call upon Benjamin. Benjamin, can you unmute? Benjamin? Hello, Benjamin?
Yes, good afternoon, sir. Good afternoon, sir.
Good afternoon. How are you?
Hello.
Yes, good afternoon. How are you?
I'm fine, sir.
Oh, good. So I would request that you open for us the session with the prayer as we move on.
Okay, let's sum ourselves for a word of prayer. Dear loving God, we thank you for the gift of life that you have given us. We thank you that up to where we are now, we would like to guide us in this lesson that we are going to have, so that we grasp anything and everything that the teacher is going to teach us. Through Jesus' name we have prayed.
Amen. Thank you so much, Benjamin, for that prayer. I don't think there's nobody who does not know my name. I'm Daniel Alira. I'm a teacher of S.5, and S.5 has not yet ended, please. S.5 has not ended. only that the schools have taken up the online sessions, live sessions. So we shall be live on YouTube. We shall be posting videos on YouTube. So you'll be watching from YouTube. If you see on the board here, right now I'm from class also. That is A-level physics, modern physics, if you can see very well for those who have covered. So people are studying, that's the truth. So we don't need to sit back and say, now that 85 hours, the free Zoom lessons have gone, now let me sit home and then I remain home. No, please try to do some work. If you can afford to join an online class, please do so. Please, if you don't have any access, I told you, you can contact me. I can direct you on what to do so that at least we keep the fire burning. We are going to make the corrections of the previous work, the exams the concluded exam. I believe most of us have received the marks. I don't know whether I never saw very well, but as if I never saw the paper. Benjamin?
Yes, sir.
Have you received your marks?
Yeah.
Yeah, I also remember for Nabudu. Nabudu?
Yes, please, teacher.
You have 90, right?
Yes.
At least I know that. At least most of you passed. For those who have been attending consistently, we've passed. And that is, by the way, some good marks. I started, when I was in senior 5, I used to get 50, 40, 45, 50, around there, okay, in senior 5. But when I reached senior 6, I think what made me to like getting 40, 50, I liked guidance on how to read. 2, I could not, whenever I would read, I would just pass on top. I would not even take things seriously. Okay, I also lacked somebody to guide me on reading. Now, when I reached senior 6, there came a young man. He was a young man. When he entered in class, we thought he was not our teacher. When he entered in class, I thought he was not the teacher. I thought he was like a visitor who had come to pass in information. But he started talking about physics. When he started talking about physics, we started seeing physics in real life. We saw physics. We said, hey, this is real physics. The truth is, the all senior 5, we did not know what physics was. Not until we met him. He started telling us about physics. We could do physics from first principle. Most of you do mathematics. I don't know why there's somebody doing PCB. But we do physics from first principle. You know, do it from first principle, you continue, and then you find yourself almost with everything. So I remember in senior 6 first term, that is when I got 91% in physics 1. Trust me, I was too happy. When I got the 91, I said, oh God, thank you so much. I never looked back. Senior 5, senior 6, I never looked back. Second term, I got 89. I was not happy. That term, when we were coming towards mock, we first did pre-mock. That's when I got around 94. Then mock disciplined me seriously. When they brought mock, oh my God. When they brought mock, I got physics 1. Physics 1, I got 37%. Physics 2, 44%. It was an O. Physics O. Mathematics 1, oh my God, I got 25%. Mathematics 2, 39. It was also an O during that time. F. That was F. Mathematics was an F. Chemistry, 45, 41. And O, though I passed the practical. In total, 4 points. 4. 1, 2, 3, 4. 4 points. Said, my God. They called academic meeting. Said, you boys are just playing. It was a mixed school. They caned us. Oh my God, our teacher caned us. But there was one teacher, he was not teaching me, but he was teaching economics. We used to call him Jean Jos. He was called Joshua. So this man, each time would come to wake us up for morning prep. He would come to wake other students up for morning prep. He would find me in class, in school alone, seated somewhere in class. He would come at around 4. Every time he would come, he would find me there. Every time he was the one responsible for morning prayer. So when they were caning me, they caned me 42 chiboko, 42 of them. Jean Jos was there, he was seated. He had the hand on the cheek like this, said for sure. After the academic meeting, he called me, said, Alira, you come. I went to him. Remember, he was not teaching me. Said, Mr. Alira, I see how you are struggling, okay? And I've seen the marks you have got in mock. It's not actually proportional to the work you put in, the work you put. But I'm here to tell you, please, these marks should not discourage you. Continue with what you have been doing. Trust me, you'll get everything well. I told him, thank you, teacher, for the advice. I'm going to continue reading. I never looked back. I continued reading. The man picked interest in me. He was this person who was a little bit informed among all our teachers. He was a little bit informed. He would go on internet, he would Google papers from Namugongo, from where, from whatever. He would go to Google, he'd print papers, he'd print for me the exam. He would print an exam, he would bring it for me at around 3 a.m. in the night. I would do the paper, I remain with the question paper, I give him the answer sheet. Remember, he was an economic teacher, so he didn't know physics. So I was sure he was not marking the paper. But he said, please, just do the exams. You give me the answer sheet, you remain with the question paper. By the time we were almost reaching, like, let's say, like it was announced September, coming to October, I had huge file of papers, huge, from Jean Josh. Trust me, by the time we were entering into November, my book had already read them. Remember, I had 4 points. Just called me again when we were going for briefing, said, Daniel, remain focused, revise now the past papers. I revised all the past papers. We went for exams. The first paper was Math 1. Mathematics 1, I counted my marks. I said, if I'm failing, I'm going to lose around 10 marks. So that means it would be 80 something. I put it minimum 80. Math 2, I counted section A, I lost 5 marks. That number 8. If you go in question bank, 2013, number 8. There was a bead on a sphere and it was released to fall down. I failed to interpret. I read the question, I failed to comprehend it. It was the only number in section B that I did not do, section A. And so out of 40, I got all the 35 marks. After the paper, the man called me and said, how was it? I said, Master, by God's grace, I've passed. Remember, we were also praying. We would do the prayer, fasting, prayer, fasting, prayer. We would fast every Friday. And our prayer was like, God, can please make us pass. We shall live to glorify your name. And let me tell you, with God, everything is possible. We never felt sick during that time. I used to have flu and cough, like after every month, but flu never caught me from October. I mean, August, September, October, November, until when I finished my paper on 27th. There was no flu. So I was okay. When results came back, I was so happy that I was one of the best in northern Uganda. The person who got 04, the F of mathematics turned to be an A, the O of physics turned to be an A. Chemistry, I failed with a C, and I had my sub-math and my GP. So I said, thank you, God, for this. And I went back to that very school to give a testimony. They called me back, said, Alira, can you come back to school and give your other learners confidence? I had my results for mock with 4 points. Remember, I was caned even. But those who caned me, I took for him a call. I said, Dos, you did something very great for me. I took for him a call. Said, get this as an appreciation. I always communicate to my teachers. They have been very good. And some of them are not there. But the truth is, when you are consistent in doing something, trust me, you can never come out without positive result. Some of us, I always see with my learners, when I give an exam and somebody fails, this person has been sleeping in books, and this person fails, he feels like he is wasted. He is nobody. That should not be the story. I've always called my students, I've always talked to them, I've always advised them. If you failed today, that doesn't mean that you're going to fail tomorrow. Neither. Settle down, get good advice, revise, pray. Everything will be okay. So the concluded paper should not make you feel like you're nobody. And if you have passed, it shouldn't make you proud. Rather, you should struggle to maintain the marks if you've passed it well. If you have not passed it, please struggle to get more marks. As simple as that. Otherwise, I would wish to continue with my Form 5s. I love Form 5 so much. And I love to teach only mathematics in Form 5. I don't love teaching any other subject. Yes, I handle physics and mathematics. But I love physics so much that, you see the problem, why I love physics so much in Form 5? People who do it, they make it look to be hard, which is a wrong impression. How can you give people wrong impression that physics is hard? Physics hard? No. That's why I mean when I'm going to my physics class, other people can be wondering, is this guy going to teach physics? Some people, when they're going to physics class, they carry this, okay? They carry this, okay? They carry this one, okay? Because you want people to know that physics is physics. You carry all these books. Now, whom are you trying to scare? You don't scare people with the books. Get a sheet of paper. I get a sheet of paper. I write my things there. I go to class. I talk for more than even 2 hours. Physics only. Physics is not something which should scare anybody. And some people, they have made it like it is for boys only. I happen to teach in girls' schools. When I went there, the teacher told me, here my girls, they fear physics. I said, it's okay, teacher, I have no problem. But we shall see what to do. Take me to senior 1. I started from senior 1. I started from senior 1. The senior ones were the ones teaching the senior 2s, the physics. You can imagine. So everything turned and it became almost the best. So let's encourage each other. Let's do this. I'm very sure at last we shall get something. But still my advice to you is, please don't sit back. Don't sit back. You say the lessons for online is done. Let me now go back and see it. Lessons are still going on, but in different formats. YouTube, I told you, YouTube on our YouTube channel, Christian School Owners Association. And you say there are other partner schools which have taken up the thing. So you can join them. I'm very sure it's affordable. So make sure if you can do that, that would be the best. That would be very okay. Before I start on the lesson today, is there anybody with any question? Is there anybody with any question? So I was saying that, is there anybody with any question before we go to the correction? If you have any question, you can ask so that at least we go to the correction. But I already told you everything is going to be fine. Thank you, teacher, for your advice. You have really energized me. It's okay. Nabudu, my work is to make sure that everybody is contented. That is my work. And not only that one, I look forward always to make sure I break contents so that at least it doesn't look to be complex to my learners. So as long as you'll be watching my videos on YouTube, please make sure you follow the videos. All my lessons will be there. Follow them, and I'll be doing the exercise. I may be giving the exercises. You'll be submitting them probably on my channel for marking. But I've told you, if you want the school, you contact me. You contact me on my number, of which I believe you have. Good. Let's go to our work. Let me share my screen with you. So here is our question paper. Let me hope you can see on my screen. Can you see on my screen? You can unmute. Can you see on my screen? Hello, can you see on my screen?
Yes, teacher.
Okay, please. So the questions, of course, they are very simple. Physics, actually physics. With the physics, now there's nothing somebody can hide. What is triple point of water? Triple point of water, we said that is just a temperature at which pure water, pure ice, and pure vapor can exist in dynamic equilibrium at standard conditions. Pure water, pure ice, and pure steam or vapor can exist in dynamic equilibrium at standard conditions. Then they're saying that with reference to a constant volume gas thermometer, explain how a thermodynamic scale can be defined. Now, to define a thermodynamic scale, of which most of us did define, to define a thermodynamic scale, you need to measure, you choose the thermometric property. After choosing the thermometric property, in this case, it is with reference to constant volume gas thermometer. So you need to know the thermometric property in a constant volume gas thermometer. Saloa. Jonathan? Hello, Jonathan? Hello, Jonathan? Raymond? Ray? Oh, you are all muted. Ngabu Jeff? Can you unmute, please? Saloa?
Yes, teacher.
I was saying, which thermometric property is used in constant volume gas thermometer?
Pressure over fixed mass of a
Very
gas.
good. Pressure of a fixed mass of what? Of a gas, okay? Good. So we're saying that with reference to constant volume gas thermometer, explain how a thermodynamic temperature is defined. So what you do, you first determine the pressure of the gas at ice point. Do you need the ice point? This is thermodynamic scale. For the other one, you use ice point. You determine the pressure at ice point. You determine the pressure at steam point and at unknown temperature theta. But here, when you're using thermodynamic scale, you determine the temperature, the pressure of the gas at triple point of water. You call it to be PTR. Then from there, you determine the temperature, the pressure of the gas at unknown temperature theta. You call it to be theta, P theta. Then you calculate theta from theta equals to P theta over PTR times 273.16 in Kelvin. Is that okay, Ray? Is that fine, Ray?
Yes, teacher.
Okay, good. So please don't say choose the thermometric property theta, X. You don't choose. They've already chosen for us, okay? They've already chosen for us that with reference to constant volume gas thermometer, can you explain how thermodynamic scale can be defined? So if the reference is constant volume gas thermometer, then we are saying in constant volume gas thermometer, the thermometric property here is the pressure. So we are saying you determine the pressure of the gas at triple point of water, you call it to be P theta. Then after you determine the pressure at steam point, at unknown temperature, you call it to be P theta. Then you determine the temperature of the body from theta equals to P theta over PTR times 273.16 Kelvin. Then number 3, part 3, I was saying that explain why thermocouple can be used to measure rapidly fluctuating temperatures. Why do we use thermocouple to measure rapidly fluctuating temperature? Salwa?
Yes, please, teacher.
Why do we use thermocouple to measure rapidly changing temperature?
I think because the metals used always have high conductivity and low specific heat capacity.
Very good, very good, very good. We gave this during the course of our lessons. I remember we gave this during the course of our lessons. Those metals have high thermal conductivity that makes it very sensitive, of course, and low specific heat capacity. So it's very sensitive to the temperature change. Then almost everyone passed this, part B. The resistance of the element in platinum resistance thermometer is this at triple point, and this at room temperature. Find the room temperature is the formula which you have just written. The formula which you have just written, we said the room temperature in this case is going to be R theta over R triple point times 273.16. Isn't it so, Jothan? It is R theta minus that times 273 degrees Celsius. So it should be 273.16 Kelvin. That will be that. Then with the head of a level diagram, describe how optical parameter can be used. Maybe Jeff, can you tell us briefly? I was interested in if the temperature of the hot body is greater than the filament. What happens? What about if the temperature of the hot body is less than the filament? What happens? Then from there we said by adjusting the rheostat, you adjust the current flowing through the filament until the filament and its background is indistinguishable. In that way, you determine the temperature of the filament, which becomes the temperature of the hot body from the ammeter, which is calibrated to read the thermometer. But I want to know, if the temperature of the hot body is greater than the temperature of the filament, what will be the appearance? Yes, Jeff. Jeff? Hello, Jeff, can you unmute? Jeff? Raymond? Ray? Okay. I think this is for finding challenges in unmuting. Jonathan? That leaves me the only one option. Jonathan? Jonathan, can you unmute? Jeff? Okay, fine. I will say that if the temperature of the filament is more than the temperature of the surrounding areas or the temperature of the hot body, then the filament is going to appear bright in a dark background. And if the temperature of the hot body is more than the temperature of the filament, then the filament will appear dark in a bright background. So by adjusting the rheostat, you will make sure that the filament and its background are indistinguishable. At that point, it tells you that the temperature of the hot body is the same as the temperature of the filament. Then you read it directly from the milliammeter. I refer you to the notes. Number one, almost everyone passed it. Those who tried, they all passed number one, most of them. We got a challenge in this part, this number, explain why a thermocouple can be used to measure rapidly fluctuating temperature. That's where we had the challenge. Good. Then part D, we're supposed to have the resistance R theta of platinum wire at temperature theta measured on a gas scale is given by this, where alpha is this and beta is this. Find the temperature indicated by the platinum when the temperature on the gas scale is 200 degrees Celsius. Explain briefly why two temperatures D are different. Yes, the two temperatures will be different because this is platinum resistant thermometer and this is constant volume gas thermometer. So constant volume gas thermometer and platinum resistance wire thermometer, they both use different thermometric properties. And we said when two thermometers use different thermometric properties, they can never agree. Salwa.
Yes, teacher.
Why is it that two thermometers do not agree?
Teacher, it is because they have different thermometric properties.
And so,
Yes.
and so,
Teacher, that is where I end.
oh, fine. And these thermometric properties vary differently with temperature. Here, that's lower, okay? They have different thermometric properties, and these thermometric properties vary differently with what? With the temperature. Is that okay?
Yes, teacher.
Good. So you have to add that one on top. And so these thermometric properties vary differently with change in temperature. So we got two different thermometers, temperatures here, simply because different thermometric properties vary differently with the temperature. We have platinum resistant thermometer and constant volume gas thermometer, which use different thermometric properties, and these thermometric properties vary differently with change in temperature. All these are in our notes. All of them are in our notes. Salwa, it's only you who can unmute. The rest are not unmuting themselves. I don't know why. Jonathan? Raymond? Jonathan, Raymond? Even Benjamin has just left. Salwa?
Yes, teacher.
Hello? Yes, Aloha. It's only you who can unmute now.
Yes.
It's like I'm talking to you only. The rest will get the recordings, okay? Saloa? Hello, Saloa.
Teacher.
Can you define for us specific heat capacity?
Specific heat capacity is the amount of heat required to raise the temperature of 1 kilogram mass of a substance by 1 Kelvin.
But Saloa, do you know you have an A of physics? Oh, you're not aware? You already have an A of physics, let me tell you.
So it's the one I want to get.
Just make sure you focus on this subject. You already have an A of physics. You're doing which combination?
PCM.
Oh my God. I also did PCM. Did I tell you that?
Yes, teacher.
Yeah. So you already have an A of physics. That means you already have automatic A. Because when you have an A of physics, that is automatic A of mathematics. So far, those are 12 points. Then automatic, as long as you see me, I got a C of chemistry. It was out of war. But if you have assistance, you have already an A of chemistry. Those are 18 points. You put there computer one. So that means you have 30 points now. Okay. Saloa, PCM is the simplest combination in A level. I don't know how you find it, but it is the simplest combination in A level. I start teaching you physics mechanics. You find the whole of mechanics is in paper 2. Okay?
Yes.
I'm talking about differential equation in mathematics. You find differential equation in modern physics. When we are talking about half-life, the rate of disintegration is direct proportional to the number of particles which are present. That is there. And when they talk about modern physics, in modern physics, you will find also modern physics in chemistry. When I'm talking about it in mathematics, in physics. So you see, they are all connected. Now, what stops a PCM student to get an A? To get 20. Me, I did not get it, I told you. But if you are doing PCM, please struggle hard. The least you can get, please get 18. And when you get 18, automatically you're on government sponsorship. Your dream will come to pass. But make sure you remain focused. The only thing which will help us to achieve that, let's remain focused. If you get any opportunity, please go for coaching, do everything. Please get all materials. You get everything, I'm very sure of that. And I see you're a very serious lady, you're a very serious girl, so it also comes with this the level of seriousness. Make sure you just do your best. Do your best. The rest will just bring themselves. They will just bring themselves automatically. You shouldn't worry about anything. But when you sit back and then you say, now the lessons are done, let me sit and wait for schools to open. By the time they open school, things will not be very simple as the way they are now. Thank you so much. That was specific heat capacity, the quantity of heat which is required to raise the temperature of 1 kilogram mass of a substance by 1 Kelvin. Is what we call to be specific heat capacity. I'm going to take the chance also to define heat capacity as the quantity of heat which is required to raise the temperature of any mass of a substance by 1 Kelvin. That is heat capacity. Part 2 was saying, with the help of a lava diagram, describe an experiment to determine the specific capacity of a solid mukama. Oh my God. I think when I was setting these exams, maybe I was even sleeping. Because how can you set such an exam for sure? You set such an exam for a girl like Saloa, for a gentleman like for a gentleman like Jonathan, for somebody like Benjamin. For sure, how can you say describe an experiment to determine the specific capacity of a solid, and then you even say using electrical method, and then you put there not only that, you again put there 7 marks. Oh, when I was marking, I wanted to change this one to 3 marks for sure, so that at least it looks to be fair. We said your solid, you make it in form of a block. After making your solid in form of a block, you make 2 holes. When you make the 2 holes, in the one hole you put the thermometer, which will help you to determine the temperature, the initial temperature θ1. In the other hole, you put the heater, which is connected to the electrical source. A voltmeter V and current I is passed. PDV and current I is passed until when the temperature of the solid increases to, let's say, θ2, and then from there you determine the final temperature θ2 of the solid. After that, you make an assumption that if there's no heat loss to the surrounding, then the electrical energy supplied should be equal to energy which is used to raise the temperature of the solid. That means VIT equals to MC into θ2 minus θ1, making C the subject of the formula. C will be the same as VIT over M into θ2 minus θ1, where C, being the specific capacity of the solid, can be calculated. For sure, Saloa. Saloa.
Yes, teacher.
This number deserves 7 marks, for sure. No. It did not deserve 7 marks for sure. It would be like 3 or 4, at least a 3. Okay, good. That was that. Then part C. Part C was a calculation. An electrical heater rated this 40 watts, 12 volts is placed in a well-insulated metal of mass 1 kilogram at the temperature of 18. When the power is switched on for 5 minutes, the temperature of the metal rises to 34. Find the specific capacity of the metal. Oh my God. Let me calculate that on the board here. Salo, are you able to see on my board?
Yes, teacher, I can see.
You can see it, right?
Yes.
So we have an electrical heater rated 48 watts. That's our power. Power is 48 watts. Power being 48 watts. And the voltage PD applied V is 12 volts. It is placed in a well-large metal of mass. Mass of the metal is 1.0 kg. And then the initial temperature θ1 was 18 degrees Celsius. It was allowed to run for 5 minutes. Time equals to 5 minutes. 5 minutes, it is 5 times 60 seconds. So 5 times 60 seconds, which gives us 300 seconds. Find the specific capacity of the metal if the final temperature θ2 became 34 degrees Celsius. You said you assume that if there is no heat loss to the surrounding, then VIT should be equal to MC into θ2 minus θ1. So VI is already power. So it's saying PT equals to MC into θ2 minus θ1. When the specific heat capacity of this solid, we make it the subject of the formula. We can substitute this. Power is 48 times our time, which is 34, should be equal to mass 0.1 times specific capacity, which you're looking for. The temperature change will be 34 minus 18, which is 16. So we shall have 48 times 34 to be equals to 16C. Divided all through by 16, all through by 16. This and this will go. So then C equals to, by 16, 1, by 16, this is a 3. 3 by 34, that is 102 joules per kilogram per Kelvin. That will be the specific heat capacity of that solid. Yes, Saloa? Saloa? I see your hands up, Saloa.
Teacher, our time was 5 times 60. Teacher, I was saying that our time. Teacher, can you hear me?
Yes, yes, yes. Oh, I've seen. Saloa?
Teacher, I was saying that our time is 5 times 60.
This is 300, right? Is it 300?
Yes, teacher.
Good. So this is 300.
Yes.
So this will be, is it 900? Isn't it 900?
Yes, teacher.
Okay, this is 900 kilograms, joules per kilogram per Kelvin. That will be our specific heat capacity of that solid. Oh, fine. Thank you. Thank you for that observation. It is already, our time. Time is already up. So, Saloa. Saloa. Hello, Saloa. Saloa, can you unmute? Unmute, Saloa. Yeah, we are ending there for now, okay?
Yes, teacher.
So in case of anything, you will contact me and then we talk, okay?
Okay, sir.
I think you have my contact, right?
Yeah.
Yeah. In case of anything, you contact me, then you talk. But please make sure you remain focused. And the rest, you are only doing class. You remain focused. Please continue reading, okay?
So, teacher, if I have a question but not under this, can I ask?
Yes, it is very fine. As long as it is in mathematics, whether paper 1 or paper 2, as long as it's in physics, whether paper 1 or paper 2, okay?
Okay, sir.
Yeah.
Thank you.
You can get into my inbox, then you ask it, okay?
Okay, sir.
Kale, please. Greet mommy, greet daddy. Tell mommy and dad the teacher is happy. They have supported you well, okay?
Okay.
I pray they continue supporting you even after this. They get for you something, okay?
Okay.
Kale, please. Send my greetings to them.
Yeah.
Good. Raymond, we are ending the meeting.
Yes, teacher.
We are ending the meeting. You greet everyone at home, okay?
Okay, teacher.
In case you want anything from me, you have my contact, right?
Yes, teacher.
You said we have schools which are running. Make sure you connect me. Connect to me. I connect you to them, okay?
Okay, teacher.
Vale, goodbye for now.
Bye.